It is time to define our interesting traffic, which in the context of site-to-site VPNs, those are going to be our traffic flows that are actually protected by IPsec. Now, anytime we identify traffic in Cisco routing or switching, you know what we're going to use. We're going to use some kind of access list. And the access list that defines interesting traffic, it's officially called a crypto ACL. And the reason I mention that is that this particular ACL, it's the same extended ACL that you've been writing since your CCNA days. The syntax is the same, the logic is the same, you can use host in any, the numbering is the same, but there's a slight twist or two in how it's applied. So that's what we're really paying attention to in this particular video, because writing them, there's nothing to it, and then we'll rejoin our lab. But the theory of crypto ACLs, we really got to pay attention to this. Now we have some rules for traffic as they leave an interface that has a crypto ACL on it, and we have a rule for traffic that comes in on an interface with a crypto ACL applied. And you have two outbound rules, one inbound. The two outbound rules. First off, traffic permitted by the crypto ACL is protected by IPsec. So in this case, on router 2, we have access list 103, permit IP host, 10112, host 10113. We know from our CCNA studies that this is an extended ACL, and it's going to demand that you put a source and a destination in. We use the word host twice to say this is the one host that we want. The source 10112, destination 10113, and when traffic matching that line leaves router 2's interface, once the ACL is applied to that interface, then that traffic will be transmitted and it will be protected by IPsec. Now, traffic denied by crypto ACL is denied the protection of IPsec, but it is not denied transmission. Be prepared to be hit over the head with that for the next couple of minutes, okay? Because it's such an important thing, and it's intuitive. You know, once you learn what an ACL does, then you look at permits, denies, and you say, oh, okay, you know, it's a crypto ACL, so we're denying transmission. No, we're not. What we're permitting or denying is actually the protection of IPsec. Very important distinction. As in this drawing, I mean, what a difference a 3 makes, because this traffic meets half of the ACL criteria, so frankly it might as well not meet any of them, because we know for traffic to match a line of an extended ACL, it has to match source and destination, not source or destination. So here, you know, the traffic matches the source in that line, but it doesn't match the destination. So what is the second line of this ACL? And I know I didn't tell you what it is because I didn't write one, but what would the second line be? It would be access list 103 deny any, because that's our implicit deny. So this traffic does not meet the ACL requirements. It will still be transmitted, it just won't be protected by IPsec. Now, the inbound crypto ACL rule, when traffic comes in on an interface that has a crypto ACL applied, here's the rule. Traffic permitted by the crypto ACL, that indicates traffic that should be protected by IPsec when it arrives. If it's not so protected, that traffic will be dropped. So what we're doing with an ACL when traffic is coming in is saying, okay, this should have been protected by IPsec when it left the source, you know, and if it still is, fine, it can come in. If it didn't, then something happened to it and we're not going to let it in. So let's review those rules very quickly. Very important stuff here. The outbound crypto ACL rules, traffic permitted by the crypto ACL is permitted by IPsec. Traffic denied by a crypto ACL line, whether it is implicit or explicit, is denied the protection of IPsec, but it is still transmitted. Then finally, inbound, it's a last second security check. Traffic permitted by the crypto ACL indicates traffic that should be protected by IPsec when it comes in, and if it's not so protected, that traffic is dropped. Here's the key to writing a successful crypto ACL. And you'll notice I kept saying something along the lines of when this interface has a crypto ACL applied to it. I never said whether we were doing it inbound or outbound, because here's another one of those twists. When you're using an ACL as a crypto ACL, that ACL is evaluating inbound and outbound traffic. There is no in or out when applying a crypto ACL as there is when writing a regular ACL and then applying it to an interface. So remember what you got to do with the access group command. You've IP access group and then the number, and then you have to say in or out. That's when you're applying an ACL to an interface to filter traffic. But as you'll see when we continue our lab, when you're applying it as part of a crypto map, There's actually not going to be in or out, because basically what happens is the same ACL is read forward for outbound traffic and backwards for inbound traffic. I am not kidding you. That's how it works. Let me show you exactly what I mean by that. And we're going to use the same ACL line, 103 permit host 10112, and then a host 10113 is the destination. Well, we saw this, but I've got it for you again because I want you to compare the two. Since the traffic is leaving router 2's interface that this ACL is applied on, it's reading the ACL forward. It's reading it normally. And it just says, okay, you know, sourced from 10112, destined for 10113. We're going to protect it with IPsec. Anything else, we'll still send it out, but we're not going to protect it. Here's the backwards part that you have to watch, because router 2 is also looking at inbound traffic on that same interface. And it's reading the ACL lines backwards. It's considering the 10113 to be the source and 10112 to be the destination when it is talking about incoming traffic. So in this case, when it does so, when router 2 does that, it's saying, hey, traffic sourced from 10113 and destined for 10112, it better come in IPsec protected or I'm going to drop it. That's the part that takes a little getting used to with crypto ACLs. But again, as I do say often, it will become second nature with practice. But that's why I'm kind of hitting you over the head with some of this. Because as I said, the syntax is the same as the application. That's going to be a little bit different. Now, this behavior makes it vital to put a symmetrical ACL on the remote VPN endpoint, not an identical one. A mirror image, if you will, and I show you the accompanying ACL on router 3. And the reason that I'm mentioning this so strongly is what people tend to do is they'll write that ACL on router 2 and then say, okay, I just need a copy of it on router 3, so they'll copy it and paste it on router 3. Don't do that, because that's not going to work. You don't need an exact image. What you need is a mirror image, and that is exactly what we would do here in just a moment. Now, you've noticed, of course, by this point, I've mentioned a couple times, and we'll see it as well, that we can only use extended ACLs here. We do not even have the option to use a standard ACL. And why not? Because well, I blew it. Gave you the answer before I gave you the question. What does a standard ACL match on? It matches on source IP address. So if we were looking at this particular network, the one we're working with in the lab, and if you were allowed to write a standard ACL for a crypto ACL, and you put it on router 2, what do you end up doing? You end up encrypting or protecting all of the traffic leaving router 2's fast Ethernet interface. And you probably don't want to do that. Maybe you don't mind, but maybe you don't want to do that. Maybe we want to have to specify source and destination. And that comes up, that brings us to this point, Cisco's recommendation on host and any. There's no problem with using host in a crypto ACL. I did it here on the board. We're going to do it here live in a moment. Cisco and your humble narrator recommend that you not use the any option for either source or destination, because what ends up happening is you end up with way too much encrypted traffic, way too much IPsec protected traffic. And whatever happens, what it can also end up happening is that you're dropping unimportant but unencrypted incoming control traffic, like OSPF hellos or something like that. So again, no problem with using the word host. We're going to do that here in a moment a couple of times, but Cisco and I recommend you do not use the any option in a crypto ACL. What we will do when we come back is add these two lines to our existing lab, and then I'll show you exactly how we apply that to the interface. We're going to write a crypto map, finally get to that part, the actual crypto map, and then we'll start some testing. That's all coming up next.